So yeah, welcome to the stream. Starters 175. I was in div 1, but we'll also discuss div 2a, then div 1 AP, basically div 2 ABC. Now, A is maxim, which is you're given S1, S2, S3, which are binary strings, and your goal is to make every character, like in every string, all characters should be same. What you can do is choose an x comma y, basically choose any two strings and swap any two characters between them. What is the minimum number of operations to do this? So one thing, let's just take it like 1 1 0 0 0 1 and then 0 0. Okay. So now these three strings are there. Here you can see just one swap leads to my correct answer. But now there are also cases where the answer can be 0. Answer can be -1. So what are such cases? If you see basically in general, the total count of 1, let's say, should be divisible by the length of each string. Why is that? Because at the end of the day, you want to make 3 strings such that it is some kind of this. Like each string will have n characters and each string has same characters. So for example, 1, the number of 1s should be at least divisible by 3. For example, it can be n, it can be 2n, or it can be 3n. All of them are valid. Anything else I can't really make because I will be left with a string with a different number of 1s than size. Okay. So one thing is, first condition is count of 1s mod 3 mod n equals 0. Okay, this is valid. Else -1. Now once I know this, what should I do? How will I calculate the minimum, right? So either, now here since there are only 3 strings, I can kinda do like brute force. Okay, for example, I make first string all 1s, second string, let's say for example there are 6 1s. Okay, the first and second string I make all 1s, but third string I make 0. So now what is the cost to do this? Cost for this is, let's say this is n minus already kitne ones, how many ones are there. Okay, that is this, same over here. Ones of 1, and here it is gonna be, now see, because here you've already swapped all the 1s, this is gonna end up at 0. So my cost is gonna be n minus 1s of 0 plus n minus 1s of 1, or else you just make everything 0 over here and then everything else will satisfy. So one thing you can make sure is there's only one string which you make all 0s or all 1s. Baki sabko 2 0s or 2 1s. Okay. Basically what I'm saying is, let's say I have n 1s and 2 into n 0s. If I have 2 into n 1s, I swap, and n 0s I swap. So then basically my cost is gonna be Now after I swap, my cost is min of n minus 1s of 0, comma n minus 1s of 1, comma n minus 1s of 2. So this is gonna be my cost once I swap everything. So I think ये क्या कर रहा है? I'll
Um,
put it.
that the test case you took in that the cost would be zero, but right? Because every string is good. Like,
As in?
uh, can you show the test case which you are
Okay,
taking?
wait. Test case, let's say it is 1, 1, 0, 1, 0, 0, 1, 1, 1, 1, 1, whatever. Okay. So now firstly I get the count of ones over here. Count 0, ones of 0 equals to ones of 1 equals 1, ones of 2 equals 3. Total equals 6. Now since total mod 3 equals 0, now what I do is, since total is 6, I now only check zeros. So now ones of 0 I make it to 1. Wait. Zeros of 0 equals 1, zeros of 1 equals 2, and zeros of 2 equals 0. So now हाँ, and then वो भी देख लो कि 0 नहीं है. हाँ. Okay. Now my minimum cost is gonna be what? Cost is min of 3 minus 1, 3 minus 2, 3 minus 0, which is cost is 1. So that is my answer. Does this make sense?
So 3 minus minimum of zeros and ones in the string, you mean? Am
Um,
I right?
Basically, like, so it is 3 minus number of ones. Ones I am taking the minimum of 1 and 0.
Okay.
So over here 0 is lesser. So 3 minus 0 of 0 instead of 1 of 0. And there's
Hmm.
just count of that character in the string. So if I just code fast string ABC, vector and ones of 3, C ones of 2 plus 1, and then I just do total equals 0 plus 2, total mod n not equal to 0 minus 1. If total equals 2 into n, I equals n minus I. Ah, yeah, I think. Um, Oh, if all of them are 0. Okay. If total equals 3 into n.
It was still wrong.
हाँ हाँ
और एक और कंडीशन
और
डालो
टोटल
0 का।
इक्वल 0
Yeah. Mm.
That's it. So crux of the problem is first count the number of ones and zeros. Total should be divisible by 3. Then just if total like ones are more than zeros, then count. The answer is 3 minus frequency of 0, 3 and n minus frequency of 0, or else it's n minus frequency of 1. So code wise, if you see, get the count, get total. One edge case was if all of them already good to 0, or else here is where I swap and then this is the answer. That's it. Now moving on to B. Alternate it. You're given a string, you can perform operations a many number of times. Odd number of operations, you shuffle the string, substring, shuffle any substring, and in any order. So best case, I'll shuffle the entire string only. There is no harm in doing that. And even number mein, just choose a substring and flip every bit. Now flipping every character means 0 to 1 and 1 to 0. What is the minimum number of operations to make the string alternating, right? Now what are the cases? Case 1, already alternating, then answer equals 0. Case 2, now when is my answer 1? Answer equals 1 when. What is a alternating string? Basically 0 1 0 1 0 or 0 1 0 1 0 1. Basically count of 1 and count of 0. It is
इक्वल और डिफरेंस
absolute difference between ones, absolute of 1 minus 0 less than equal to 1.
1.
This is when I can just shuffle the entire string and make it alternating, right? So this is the case when answer is 1. This is the second case. So we'll just write it over here. Case 3. Now what if I make answer 2, for example? When can I make answer 2? So now my claim is why is this true? Okay, so let's take a random string 1 2 3 4 5 1 2. Okay, here the absolute difference is 3. Okay, when I shuffle, let's say I shuffle it like this: 1 1 0 1 0 1 1 0 1 1 2 3 4 5. हाँ ऐसा. After shuffling, this is operation 1. Now can I take this substring and flip it? Let's see what happens. 1 0 1 0 1 0 1. So this is valid. What am I doing here is I am flipping 3 characters and I am making 2 characters 0. And main thing to note, 1 का count increases, 1 का count decreases by 1, 0 का count increases by 1. Wait, over here what is happening is 1 equals 5 0 equals 2, 2 1s equals 4 and 0 equals 3. Basically 1 का count decrease किया, 0 का count increase किया. Now if you see, absolute difference is 1. So now this I can make. So I shuffle it accordingly, अच्छे से, and then I make this thing. Okay. Anything greater, let's say I do 6 and 2. At max I can reduce and increase by the same amount, right? Because I'm flipping. जितना 1 से reduce करूँगा उतना 2 से increase करूँगा. And once again I have to make alternating also. So like alternating में at max I can do like 1, 3 or something. So it is best. Here I can make it to 4 and 4. But this will not remain alternating. You can try it out on your own. So now this is the case 3, and the last case is answer equals 3. Why is this the case? This is very important. This is a base case. For example, I have 1 1 1 1 1 1 1 0 0. Okay. First operation, I let it be like this. Okay. Second operation, I make count of ones and count of zeros within the absolute difference ka range. So for example, here there are 1 2 3 4 5 6 7 8 9 10. So 1 2 3 4 5 1 2 3 4 5. Okay. And now I shuffle. Right, 1 2 3 Wait, 5 maybe. Yep. And now I shuffle and I get my alternating string. So it took me 1 2 and 3. That is why worst cases, my answer is 3. Basically bring all ones together, that is my first operation. Then change, bring all ones together, bring all zeros together, balance the frequency of 1 and 0, and then shuffle it. That is 3. So these are the only answers. So if you see my code, how do I check alternating? I have a previous character. If previous equals current, then alternating becomes 0, or else alternating was 1. Okay, so that is the alternating case. Then the difference is 1, 3, and x. That's it. Does that make sense? Cool. So then moving on to multiplexer. Multiplexer, you are given an array A and a positive integer x. You are allowed to perform the following operation at max once. Choose a contiguous subarray and multiply each element of the subarray by x. Your task is to determine maximum possible frequency of any element in the array after performing the operation. Let's take this string, this vector x equals 5. Okay. Now over here my optimal cases, I choose this subarray, multiply by 5, and I get 10, 10, 40, 10, 4. And over here frequency of 10 is most. Okay. So now some base cases. Answer can be maximum frequency in array, right? If I don't do any operation, or else at most once, so if I don't do any operation, my answer will be maximum frequency in the original array. Fair enough. That's the base case only. That is only one base case. Now let's say, now I want to do the operation. This is basically no operation done. Now when I do an operation, I have only one operation, so I want to maximize the, like, I have to choose it very wisely, right? So how do I choose it? One thing to notice, when I multiply, let's say ax equals b, there is only one a. There's only one a which leads to b. There is no other a which leads to b, right? So if you can see, a and b form a pair. Pair as in, I can technically make all a's into b by multiplying with x. Now, should b also be present in the array? Should b be present? A already is present in the array. Should b be present? Yes, because if b wasn't in the array, my frequency just becomes my frequency of b equals frequency of a. I'm not increasing anything, I'm not decreasing anything. This to I had calculated over here only. So this is very important. The frequency of b should be present in a. Now, after b is present in a, now what do I do? So now, let's say I take, now my approach is get max for all pairs a comma b, such that ax equals b and a and b are present in a. Okay. Now, what is the max if I choose a pair? For example, let's say I have 4 7 4 4 7 7. No. 4 8 4 4 8 8 8 8 4. Okay. Now there is a pair. Let's say beach mein there is a 1 over here, 3 over. Okay. Now, this, if you look at it, this kind is exactly what cadence algorithm, like, this is like, you can do this with cadence, but how do you come up with the approach ki cadence lagana? Right. I'll also tell you what is cadence later. So, now given this 4 4 8. Now, one thing to notice, 3 and 1 don't really matter to us, because even if I multiply, they won't change my frequency of 8 or they won't change my frequency of 4. So 3 and 1 I can just remove. I can have this array. 4. Now, if I choose this entire subarray, what will my frequency become? My frequency of 8s. My answer is frequency of 8, no? So my frequency of 8 is frequency of 4, because I am just removing all 8s. So technically, whenever I am choosing a subarray, number of 4s, say, frequency of b increases by frequency of a in subarray minus frequency of b in subarray, because b will also become something else, right? So now, if you see, technically now, with respect to frequency, these become 1 minus 1, 1 1 minus 1 minus 1 minus 1 minus 1 1. Okay, so now if I take this into subarray, my frequency gets deducted by 1. If I take this into subarray, my frequency gets increased by 1. So now here I can apply cadence. Cadence algorithm basically gives me the maximum substring sum. Okay, if you just search cadence algorithm, you'll get maximum subarray sum. And yeah, there is this algorithm. You can just copy paste from here also, but it's very simple to write also. Okay, I'll show you the way I write it. So yeah, now here I can do cadence. So now what is my final frequency of B? It is original frequency of B plus cadence plus whatever cadence gives me. Okay, this is my maximum value. That is my final frequency, and my answer is max of answer comma frequency of B. Final frequency. So now this I do for every single pair. Now what will be the time complexity for this? So now my algorithm is for all pairs A comma B, make 1 minus 1 according to indices, and then do cadence and take max. Right. So now for all pairs, how many such pairs can be there? For example, it is for x is 2 and I have 1, 2, 4, 8, 16, whatever. There are very limited number of pairs. Okay. Now forget the number of pairs. Okay. For right now, forget number of pairs. But how many indices will I traverse? Cadence algorithm does an O of n. O of size of array. This happens in O of n. Not O of n. This happens in O of size of array. Okay. So, worst case, every number, let's say A comma B, then B comma C, these are the pairs, C comma D. B comes twice, C comes twice, and so on. There are worst case n minus 2 numbers. I use their indices twice. So you can just assume it is 2 into n. And I'm just taking those indexes. So total size of my arrays, all the arrays I'll build, will be 2 into n at max. So at max 2 into n. So this basically like sum of all arrays, sum of all n is less than equal to 2 into n. Now, so that is why O of n algorithm will work here for every single pair. And now if you just come to the code, first I have a map of value comma indices where it is present at. Then I check pairs. What is it? I iterate over all the unique values, and firstly my max can be the size itself, like only that person itself, I, or else x not equal to 1, and the value into a into x exists in the map itself. So I push back a comma b. Now for all a comma b, I have my current frequency, the original frequency, and then what do I do is I iterate over indices of a and b. If I, like index of I of A is less than index of B. Index of A is less than index of B. Then I push back 1 because that comes before the minus 1. And then I do I plus plus, or else I do minus 1 and do j plus plus. And at the end, this is very important. If j as all j's are over, I'll iterate over all the a's, basically all the remaining a's. Iterating over remaining b doesn't make sense because those will be minus 1 only, and they will just be neglected by Cadence. And now this is my this thing. Now Cadence algorithm, if you just look at the code, I have two variables, max and cur. Cur is max of 0 and cur plus I for every value in AI, and max is max of max comma cur. That's it. Very simple algorithm, but very powerful algorithm. So yeah, that is the approach and that is the essay. Any doubts? I
No.
guess not. So bye bye stream. See you tomorrow. Tomorrow div 2